a very limited extent, we can control the pH of our cells, right? In the blood, we've got bicarbonate, and that's how we balance the blood. In the cells, we can import things and export things. We can also neutralize certain things by taking them into lysosomes or peroxisomes, but we cannot, the cell will just fall apart at 2. Okay, we've got a really narrow range. So there's a little bit that can be done there, which changes, how the enzymes are working. So production, upregulation, downregulation, like I said, if I go there, we'll be not on time. We're going to talk about that in a couple of weeks. It will make way more sense in a couple of weeks. Competitive inhibition. Okay, so there are a couple of different ways that enzymes are controlled. The first one is simply how much enzyme do you have, right? And the substrate fits into the enzyme, it's being used, then it releases it, and it's open to take up another substrate and catalyze another specific reaction. The enzyme can actually be used by something else. That is competitive inhibition. Something that has the same general shape as the substrate randomly, probabilistically collides with the enzyme and gets there first. Sometimes this binding is temporary. It's, nanosecond, it just fit in and it's not it's kind of a bad fit, but it's good enough to stay there for a little bit. Sometimes it fits and it just sits there for a long time. That enzyme, either way, is not available for use. That's competitive inhibition. It is direct blocking of the active site by another molecule. Okay, so allosteric regulation is something else. Allosteric regulation is when a molecule binds to the enzyme at a site other than the active site, somewhere else. When this happens, it changes the configuration of the molecule. It can make the active site more likely to receive the substrate or less likely. It is one way, once an enzyme protein has been produced, it is one way whereby the cell can control that so if it's got too much going on. A lot of times, in the cell, the substrate itself will act in a negative feedback loop. What that means is if you've got a ton of substrate, right, and you don't want to catalyze that reaction anymore, and just to be clear, I always say you because I think it's easier to kind of personalize. There's no determinism in any of this. This is all about probability and random. I teach the population genetics part, and I'm talking about you, and I say 100 times, it's not deterministic. It's whatever happened happens to be here. So when I'm saying you, I'm not implying that there's a driven way it has to be. It just helps me to anthropomorphize so I